The world is full of colors, some vibrant, some dull, and some that are all in our heads. In fact, you are looking at a color on your screen right now that, in a sense, doesn't exist. Unlike virtually all other colors, there is no wavelength of light to describe it, but we see it anyway. It's magenta. And it is nothing but a trick from your brain. Our eyes can see things because in the back of the eye there are millions of receptors called rods and cones. Rods are sensitive to light intensity and movement, while cones are the receptors that see color and fine detail. There are all kinds of cones out there in the animal kingdom, but humans have 3 types of them. One that detects long wavelengths, like red light, one that detects medium wavelengths, like green light, and one for short wavelengths, like blue light. When light enters the eye, it causes some of these cones to fire depending on what wavelength it is. So if you're looking at a red apple, your long wavelength cones might fire, or if you're looking at the sky, your short wavelength cones, or blue cones might. But as you might have learned or noticed, there are more than 3 colors in the world, so how do we get by with only 3 types of cones? Well, our eyes kind of cheat, because while each type of cone is most sensitive to a specific color, they actually respond to a range of wavelengths, and most importantly, those ranges overlap. So say you're looking at something yellow. On the visible spectrum, which is the range of wavelengths we've assigned colors to, yellow is between green and red. So if you have typical color vision, when you see a yellow object, your red cones fire a little and your green cones fire a little, but your blue cones have no stimulation. Your brain interprets that unique pattern and knows whatever you're staring at must be something in between red and green, so yellow. Something similar happens when you're looking at cyan. In that case, both your green and blue cones fire because cyan is in between green and blue. But what happens when you look at an object that makes only your red and blue cones fire? At first you might think you'd see green, since on the visible spectrum, that's the color in between red and blue. But remember, your green cones aren't firing. So what does your brain do? It makes up a color! And this is what we see as magenta. Unfortunately, it's hard to say exactly why our brains make up this specific color. Like, there's nothing that seems to be particularly special about magenta, but we see it anyway on everything from billboards to t-shirts, and that is really weird. I mean, pretty much all of the other colors we see have one specific wavelength we can use to describe them. But that's not true of magenta. The color is nowhere to be found on the visible spectrum. It's just the odd way our brains happen to respond when hit with red and blue light. This makes magenta what's called a non-spectral color, a color that can only be described by combining multiple non-adjacent wavelengths of light. It sounds bizarre, but our brains do this sort of thing all the time, processing the world in strange ways to help us make sense of all of the weirdness around us. And hey, if it gets us a nice color like magenta, it can't be all that bad.